Hello, this video here is going to show you how you can do antiderivatives and indefinite integrals using Mathematica. I'm going to be doing a few problems showing you how to answer it with the commands and how to answer it for how your math homework would probably require it. And I'll also show you a screenshot of whether this answer was correct or not correct. So we'll start with question 22 here. It says, find the particular antiderivative of the following derivative that satisfies the given condition. So whenever you're finding the antiderivative, it's almost the same thing as finding the indefinite integral. And for both of which, you're going to use this one nifty command called integrate, which is pretty logical. Integral, you integrate integrals. So integrate starts with a capital I, like every other command on Mathematica. The word integrate, then you open a big bracket. Within it, you put in the expression, which in this case is 3e. You can either enter by pressing escape escape, which would produce the e symbolically, or you can just do capital E, which also um, has the same meaning as the escape escape. And this here is to show you. Capital E equals symbolic E equals the constant 2.7. So now that we've shown that, go ahead. 3 capital letter E, control 6 so that you can add the power. T, then minus 3, comma T, since you're differentiating in terms of T. Close bracket. Shift enter, and voila, that's your indefinite integral here. But um, before you record it, don't forget to add your constant, your arbitrary constant, which is, let's just call it plus C. Looks like I have C defined here, so I'm going to clear C. And now it's not defined again. So this here, as you see, or actually, you know what I'm going to do? I'm going to do shift enter so I can have it, record it, and then I can manipulate it on a different line to not lose track. So plus C, and then we go back to the question. It says x of 0 equals 1. So that is to say that the function, which is f of x, which is, in this case, 3 times parentheses e to the t power minus t, that is your x of t, or f of x, whatever you want to call it, x of t in this case. So this here is the x of t, and then the other side, after the equal sign, is the 1. So we know we got to add a constant, arbitrary constant, which is c, and we're trying to find the constant that satisfies the condition. So we have the function here, 3 parenthesis e to the t minus t, close parenthesis, plus c, equals 1, which is from the question, x of 0 equals 1, shift enter. Well, we're not going to stop there. We're going to come and say replace all, which is slash period, x, and then dash, bigger or lower than, which combined gives you an arrow. So we're replacing the x for 0, just as in the question, says x of 0 equals 1. So now we press shift enter. It suggests to give me, oh, sorry, it's not x, it's t. So we replace all t for 0. It's just by habit, we usually use x, but it's t for this case. So once you replace t for 0, it suggests to solve for c over reals, which is what you want. So solve for c over reals, and you get that c equals minus 2. So your indefinite integral is what you got from the integrate command plus minus 2, which becomes minus 2. And this here's the answer. I'm going to record it and see if it works. Oh. Alright, seems like I was solving a question that does not match the one I have right here, right now. This is the one I have. So instead of 3e to the t minus 3 is correct. So everything's correct except for it's equal 2, not 1. So now we do shift enter. This here we make it a 2, but since it's x of 0 still, so t replace all t for 0, and now solve c over reals and you get minus 1 instead of minus 2. Let's record that answer and see what we get instead. And voila, that's the correct answer. We can now move on to the next question, and here's the screenshot. So next question says, it's also something similar, but here they give you, find the equation of the curve that passes through 3, 4 and its slope by giving the following equation. By the given following equation, so you find the integral, etc., etc. Only this time, instead of just sub in one y value, you sub in an x and a y value since you have a point. Let's just stick to, I think this question would work better for this video's purposes, question 24. This here is of the questions that you would typically see where they give you a symbolic, the symbolism for the integral or the integration. It says find the indefinite integral. Here we found the antiderivative that satisfies the condition. Here it's more straightforward. It's just find the indefinite integral, which is the same thing as an antiderivative, only we don't need to do we don't really need to find a value for the arbitrary c. We're just going to leave it as that. So again, we go ahead, we do integrate, open bracket, x to the 8th minus 5x, shift enter, shift fraction, but you need to highlight it. Gives you the fraction, and then x to the 6th power. Minus 5x, yeah, that is correct. Shift x, which tells it what you're integrating for. Shift enter, and this here should be your integral. Of course, don't forget to add the arbitrary c, so plus c. And this here should be your y of x, or whatever you want to call it, f of x. Let's record the answer and see if it works. Okay, check answer, and the answer is indeed correct. Let's see if we can squeeze in another problem in this video. I'm trying to keep it short. See if we can find something that covers some grounds we didn't cover. For the most part, it's all the same stuff. We can do an econ problem here, a business econ problem. So question 28 says, the marginal average cost of producing X digital sports watches is given by the function, the average, and then they want the of 100. So this is pretty straightforward. Again, right away, you have a function, you need to integrate it in this lesson's context. So first things first, just do the integrate function, integrate the 1300, make sure that that negative goes for the whole fraction, x to the second for x, so it's 13x, and you know that this is, of course, plus your arbitrary c, but since your arbitrary c needs to have a value, and at c of 100, it equals 25, so we're going to set this equation here, our indefinite integral, equal to 25, shift enter, and now we're going to replace all of our x's for the value given, which is 100. So replace all x for 100, shift enter, solve for c over reals, and now you know the value of your c. So this means that this here is your answer. Let's record it and see if it works. The answer is correct. question seems to have two more parts. So they want the cost function. So the what we just found was the average cost function. The average cost function is the cost function divided by x. So to find the cost function, we're going to go ahead and take our average cost function, which is this guy. And since normally you would divide your cost function by x to obtain the average cost, here we're going to multiply it by x to obtain the cost before its average. This here I would assume is our correct answer. We might have some formatting inconsistencies with, no, that worked. And this is the answer. And now they want the fixed costs are, the fixed costs we're going to get from the cost function, I assume, by plugging in the same 100. Or actually, I haven't faced this before, so let me look through it real quick and see how they would take the fixed costs. So, oh yeah, the fixed costs, of course, is your costs without any production, stuff that you have to pay anyways. So that means that production is at 0. So since we know that our cost function is basically c of x equals 4 times 325 plus 3x, which is a verified correct answer from, as you see above. This here is our cost function. So what's c of 0? It's 1300, and that should be your fixed costs. Let's check it, and it's indeed a correct answer. Alright, well, thank you for watching this video. This took you through all you need to know about indefinite integrals and antiderivatives. I hope you enjoyed it and learned something. Bye.